Sometimes textbooks try to make word problems to get you practice math, but the word problem itself fails miserably in being authentic. This is one such example. Clara and 3 friends were born all on March 11th. That's amazing. Leslie's 5 years younger than Clara. Mike is 2 years younger than Clara. Thomas is 3 years older than Clara. And somehow you don't know how old they are, but you happen to know that the product of their ages is 61,136 greater than the sum of their ages, because that's common known fact. And you want to find out how old is Clara? The answer to this question is ask her. She'll probably tell you, right? There's no way that you know this obscure fact that the product of all of their ages is 61,136 greater than the sum of their ages, but you don't know how old they are? This is a great example of, it's a good problem for us to practice, but it's a bad problem for being realistic. The first problems, the maximum volume, I think those are awesome problems because it's actually, like, you can see businesses wanting to have that as something useful. They want to minimize how much material they're making and using to make the maximum volume. Makes total sense. So it could save companies money. This is ridiculous, but we'll solve it anyway. So everybody's compared to Clara, so we'll say that she is X years old. Okay? That makes Leslie, who's younger, X minus 5. Mike is younger. He's X minus 2. Thomas is older. He'll be X plus 3. And then we have to create some sort of equation that looks at the product and the sum. Of course, they're not equal. It says the product is greater. So does it make sense if the product is greater, the sum number would be less? To make these equal, this is the side I would have to add 61,136. Does that make sense? The product is bigger. This side is bigger than the sum by 61,136. So if I want to make them equal, I would have to add to this side the sum of their ages. The product of their ages is right here. This is the product of their ages. I'm just writing it out in words. This is their sum of their ages. I'm just writing it out in words. Now I'm going to write it out algebraically. How do you write a product? You multiply everything. This would be the product. Equal to, what's the sum? Well, if I add these together, you see that I have 4 x's. If I add my numbers together, I'm going to have minus 7, minus 4. And I still have to make them equal, so I have to add this 61,136. And what we're going to do to solve this is use a graphing calculator. And when you have 2 things in an equation, you can type one side into one equation. You can do the same thing in decimals. And the second side into another equation. So I'm going to go to my graphing calculator. I'm going to go to y equals. I'm going to write the, oh my goodness. I'm going to try to get to y equals. There we go. I'm going to write x times x minus 5, bracket, bracket, x minus 3. 3 or 2? 2? Bracket, and then x plus 3, right? That was the product. And the other one, I'm going to write 4x minus 4. I could have combined these like terms, but I can write it like this as well. Yeah. Oh. Now, when you hit graph, you're going to have to try to make your windows so that you can see them both, and then find out where they intersect. Oh, so close. Once you get your graph so that you can see where they intersect, under second, calculate number 5 intersection, push enter on the first curve, enter on the second curve, and enter again, and we get x is 17. Should have just asked Clara, but Clara's 17 years old, and that's how we solve this.
Mr. Peggy, to the office,
If
please.
you like to do more
Mr. Peggy,
questions
to the
that have no
office.
bearing on reality, try 7 and 8.